Let's take a look at how we could apply and further refine everything we have learned from modeling the olive oil bottle and do this now with the Nutella German deliciousness jar. Interesting aspects here. It also is circular at the top where the cap is, and then there's actually a transition to an irregular bottom shape. And in this tutorial, we also will cover how, for example, we can create a cap with such intricate details. There are obviously always many ways, but because our goal will be to create study designs and best actually also the geometry for the final design, we will try to learn a process that is more suitable for how we would later work with the data in Fusion and Alias than, for example, how maybe I would build this only if I only just would have to make a render model. So let's go to Blender. And as you can see here, I also started with the cross sections and side profile curves. Those are all Bezier curves. And this again helps me to identify sharp edges, which I can measure and then use as a reference when I start sculpting actually my design over it. So for example, which I have on this layer. And you see this design is actually pretty close to my outline. I also, as you can see, did not round these edges. I simply kept everything sharp edged because the rounding later I will take care either with this double subdivision technique I showed in the past video of the olive oil bottle, or I will actually send a sharp edge model to Fusion and then round it there. So here on this layer I also have my geometry for the cap. So for example, you can see just the profiles and dimensions, but also kind of like these lines. So 2 millimeters down is actually where, for example, those elements start, and then 2 millimeters from the bottom up there's a small ring, and then these elements start. So this is actually kind of like a helper for me to know where elements have to be. Then in this video we will also cover how to build three-dimensional text based on vector graphics we can find online, because very often, like with Nutella, chances are instantly slim you find the actual Nutella font for free with good quality. But for this exercise, all we need is just these letters, and then we rotate them around so it looks like they follow the path. And it's faster to do this actually in Blender than doing something in Illustrator and exporting it and importing and changing, going back to Illustrator. Why not just do it right here? We will then obviously also take a look at how to make those grooves and cuts and add it to the basic model for the cap. For example, a step how I started the beginning, just a very simple screw command. Also, I will show a different way how to build a very simple technical screw. And you see actually it's a bigger one, and then we just trim it to the size we need. And for example, then how to sculpt something like this. Okay, so I have here this screw command. And now here I have, for example, this finish part. So how did I get to there? So you see this actually is the same shape, just following it. And let me turn off the subdivision surface modifier. Let's make a copy, and I move this one to layer 9 there. And let's go to there. And for example, now we could say, well, let's set this all to 6 because that is roughly the amount of cross sections I only need. You see there. And then maybe let's add a subdivision surface modifier. Let's kick those out for the moment there. but then everything gets very, very soft and round. And I know I have to scale and move all these points away till I kind of like get back to this original profile, which can work, but it is kind of complicated. What happens if maybe I add an edge split before the subsurface? Oh, then I get this. So unfortunately, this is also not 100% usable. But what happens now if we maybe say apply and apply? So let's see. So what happens now with this edge split? You see how everything got split. So not really usable. So remove the double. So this is all one mesh again. And then if we turn this one on, we get this result. But that's now actually where our edge creasing comes in to be very handy. You see, I select actually all those profiles here. There, 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 and there. And then edge crease. And I forgot those. Sometimes we have to go into wireframe mode to better select through an object. And we're close, but not really 100% there. So now I could AA, S, Shift Z, and for example, scale everything apart. In this case, it might make sense to turn this one on. So you see now it projects it on it, and then I just have to scale till it perfectly lines up. There. Okay. Now that wasn't too bad. So, pretty easy. Good. Okay, so now how do I get it to the side? And that's actually now where I can simply select those loop cuts and scale them in. But actually you see I have here one cross section and I want the surface to stay there, so I actually have to insert a loop cut there, also sharpen it or crease it with Shift E and then 1, and then actually all this I can select S and Y and for example scale it down till it kind of hits this area I need. S and Y there. Okay, maybe this is too far, so S and Y there. Okay, so you see very quickly we actually got that result. If, for example, now we apply the same technique from last time, like with a double subdivision, we can soften those areas a little bit. And then again, we can select, for example, this loop cut and maybe say 0.5, make it a tick softer. And maybe let's do the same here, 0.5. Let's compare it to how it looked before and then afterwards. Okay, so, but I made a mistake at the beginning. So I just went ahead with 6 points. And then at one point I realized, oh, this side edge here actually, it's not as elliptical in real life. No, because I only have those few points, there isn't really much I could do. I could, for example, select these points there and there and there, and then maybe, let's say, S and X, scale them away. So you see now this area gets a little bit more boxy. But then, for example, I also have to select this, and SX, scale it back. Yeah, okay, so works to a certain degree. Okay. So you see there again, just by the amount of points or by how these points are oriented, I can sculpt and actually certain cross-section looks. So let's go to here. Yeah, maybe like this. And then back to there, 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 there. S and X and scale it out. Okay, that's not too bad. And maybe I don't really want this double subdivision trick. Maybe because you can see actually also here it rounds those edges, but maybe I just want this model to be already a little bit more roundish. So for example, here now I simply apply a softer value. So now I have a nice mix between sharp edges and then here this rounds, but maybe this rounds a little bit too much. So let's see what happens when we add another cross section in between, and you saw that immediately this got a little bit tighter up there because now the distance between this loop cut and this loop cut is shorter because we have this new loop cut, so it tightens a tick. If I do the same here, it tightens a tick as well. And you see then this way I get back to kind of like this linear look with rounded edges, because here this is too organic. I want something like this. Okay. Now, this area is a little bit problematic at the bottom, so let me simply cap this. And maybe the issue I have is, you see, this is a bigger distance than the side, and that happened simply because we did a lot of scaling, and that actually distorted slightly the distance. So let's say I want always the same distance. So in this case I could scale it till it eyeball wise is perfect, but it's not very good. So we do simply it this way. So I set my pivot point to 3D, I extrude, and then press S to scale, Z for the Z axis, and 0 to scale it down to the 3D cursor, and then I can fill it. Okay. And what I will do now is actually I simply will create an insert face again. So insert face, there it is. Let me double check something. It's also important that the scale is correct, because if the scale is not correct, your insert will be slightly off. And now this loop cut here I can simply remove. And now there you see this is a nice and even angle all around. Also, as a quick study or finish, we can take this, make another insert there, maybe like this, and another insert, and then this, for example, we push in a little bit there. That's dipped in. See, very, very easy. Okay, but obviously it's not really a smart idea, because now we have a really narrow base, so it probably will rather tip over. So I just showed you this case or this way to fix it, just so you know it, how to do it. Obviously in our case here we rather want something to be more like this, so we can fill it, and actually we can really scale these parts in, so we chamfer that corner a little bit, and then another eye and another eye, and then this one we dip down, zip there. So this will be more stable. And because actually I scaled this loop cut straight down to the 3D cursor, you also see that these loop cuts are all from this view perfectly vertically aligned. So I get a nice flat surface. Just here it comes down and then it angles. Okay. So let's continue and take a look at the threading. But before we do the threading, we have to add a little bit of material thickness to it. Now, the upper ring where we put the cap on is more sturdy, so it has a thicker material, and then down to the bottom it is softer, so you can compress it more. Here you really need stability, here you don't need as much, and wherever you can save plastic during the injection molding process, you also save production costs. So what will be the easiest way? To make this one 2 millimeters and then scale the rest, or where everything is very irregular, make it like, let's say 1 millimeter, and then by hand adjust the 2 millimeter thickness for the top area. So obviously step 2 will be easier. So what I will do is I go into edit mode and then select everything, type in spacebar and solidify. Okay, and then I can press T and go to the thickness, and I think this is now 0.001. Yes, this is actually 1 millimeter, because again I work in metric. Can, for example, double check this, show me the length. Yeah, 1.5 millimeter roughly. Okay, so this is actually not even. Let's do it, for example, with the screw modifier, sorry, the solidify modifier. So 1 millimeter. High quality, even thickness, and then apply. And let's check this one. No, it's the same. Okay, but that's okay actually, because it's just more or less the distance. So yeah, and this is slightly at an angle. So we can, for example, go to the side, and all this is roughly, as you can see, evenly out. There's maybe a little bit here and there of crookedness. The lower part all is okay. Here maybe this is a little bit crooked. So with a quick boundary box set SZ0, I clean this one up. Same here, SZ0 there, SZ0. So I know this way I cleaned this a tick. And then, for example, now here the fun starts. So this, and nope, this and this and this, I all delete. Okay, and then I select this last loop cut down there, press E, Z, and then snap to the height. Shift, loop cut, click the other loop, so Shift Alt, Shift Control on my side, and then type in bridge, so I cap it. Okay, so now we have a quick modeling. You see how this is actually thickened up. So this whole thing actually should be at the top 2 millimeters, and you see this is roughly at the 2 millimeter marker. So let's see what we can do actually if, for example, we would scale this one down, but I feel like this is roughly a millimeter here. Yeah, okay, so we don't really want actually to get this line further to the 2 millimeter mark, because then here we make it even thinner. If, for example, our target is that the lower part of our bottle remains being 1 millimeter roughly this thickness. Okay, so that's actually fine. Just as a test, I'm going to make another copy because I want to double check something. So this I delete, and then I select all this. Okay, A, solidify just the command, because I want to see if actually the loop cuts are more or less the same. Yeah, they actually match up. So you could also utilize that command because it gives you the same result. Very often, because I'm so used to use the solidify modifier, I simply add it, set it up, and then I do all the other commands then by hand. Okay, so this can go. Okay, so there's now our bottle actually that can be used to add the threading to. So let's take a look at the threading. And it's on, which layer is it? It's there. Okay, so the threading actually is very, very simple. Yeah. I, for example, made myself a small study. So this is, for example, I think 3 millimeters tall and a little bit under 2 millimeters wide. And you see I stacked actually another one and another one to see kind of like the distance I need for the one above, which will help me to understand how to, for example, set up the screw command. And then I have here just this cross section. And it uses actually the screw command. You see, instead of one iteration, it does 2 iterations. And 4.5, that actually helped, or I came up with this number by aligning actually my screw value till it perfectly matched, for example, this upper profile. You see here's the start, there's kind of like the end or the midpoint. So if I do just one, you can see that better. So 4.5 millimeters there. So now I know actually that the distance of my threading probably will be good, and there will be a nice and tight, maybe take too tight catch between the bottle and the cap threading. So but then how did I actually get to the result where everything is capped? So you see actually I have very basic planes here. This is actually all in one and the same object, but they're slightly angled. And then I have this one here. So what I did was I simply make a second iteration. And then, for example, with these flat faces, because again, it works like a trim, I trim off the complete start and cap it at the same time with that command. You also see that my threading actually, the surface is a complete face, it's filled. So I have all these points that describe actually that shape. And then I have, for example, here, this face there. So, for example, I can cap it there. But then actually there's a gap in between. So how I need to get this start a little bit to the right. So this part I have to rotate over. And that's basically what I did. So I switched my 3D cursor to the center of the threading, selected this geometry, and then switched to 3D cursor. And then with Alt D, I make a clone, and then R, you see I can rotate it around the center and will always perfectly sit right on where that threading is. And the only thing I have to do later is just adjust the height so it perfectly cuts through the object. That is very important. This object is set to wire, so in Solid you see it's just a face. And then I add this to Boolean, and there it's cut. Also, the orientation of each face is important. So you see wherever the face actually looks to, everything to that face will remain, and then everything afterwards will be discarded. So for example, if I flip this, hold on. well, my piece now is invisible. Hold on 1 second. So let me turn this one off there and flip. Now you see I maintain just this part of my threading, and if I flip the direction, it cuts it away and keeps the rest. And that was basically everything to create this type of a threading. So you see I don't necessarily sculpt actually the end, I simply trim it. And this is also a solid part, so I can later then perfectly add it actually to this bottle. So when I go to the bottle, say Boolean union threading, should be this one. Yeah, there it is. Perfect. Now these sharp edges, that's fine for our concept model in Blender. If, for example, we maintain this geometry later than in Fusion, we simply round all these edges. That will be perfectly fine as well. And I have actually this model here as well. And you see there the result is a little bit finer. So if I go to edit mode, you see this is actually a very dense mesh. And the way how I built this was actually very simple. So let me go back to my trimmed version. Shift D, Shift H, turn this one off, turn this one off, 64 steps, apply. So I have plenty of steps, which means from the last loop cut to the next one, there's only a small transition. So that is fine. So now actually I can, for example, say you, fill, fill. Actually, K, click, control, click, and click. I make a cut there in between. You will see later maybe why. And then I can select these points, press GG, and now you should actually memorize the value here with the slider where my mouse is. So maybe I do -0.5. Okay, so I have to do the same here now as well. So U, F, U, F, K, click on this point, control till it snaps to the midpoint, click, enter, done, and then U, GG, 0.5 minus there. Okay, so if we now actually turn on the subdivision surface modifier, well, we get this result. Not too bad, not very interesting either. So next thing, maybe select all these edges, and then maybe we will do some edge creasings. So let's go to there, edge crease. Okay, so this already looks much more interesting. Also the beginning is softer, a little bit rounder. Not too bad. So maybe this is, should we keep it there? We could maybe GG and see, no, 0.2. Then we have to do the same here. GG, 0.2. Yeah. But also the ends actually get tighter. So actually I select this point and this point, and then press maybe, let's see, scale along bounding box. So I scale them towards each other, maybe 0.5. Okay, so that's fine. This also means this one got a little bit bigger, so I have to be careful now. So let's see how much I could do this. So what's this? 0.8. Okay. Then the same here, US.5, US.8. Oh, there. Okay. Also not bad. Okay. Um, What happened to this point here? This shouldn't have happened actually. So I would like to get this one to the midpoint between them. A little bit tricky, but not really. So GG. Slide back to this edge. Now you see this line is straight. GG to the midpoint is actually 0.5. Done. Let's do this here one more time. So I slide it with GG to an end. GG along this edge 0.5 to the midpoint. And cleaned up. And now I have this midpoint here at the center. See, when I sculpt this one out, or there, sculpt this one out, you can get this shape if you want to. We could also select the complete loop, but then you have to deselect the inside. And for example, if we press S and Shift Z, we can scale it a little bit out. So you see we dome this part a little bit. And we could even at this point maybe do a double subdivision, smoothing again. There, see, now we actually get a nicer, crisper look this way. However, this is an insanely dense mesh. You don't really want this to be used for Boolean operations, so something like this still is more than sufficient. Okay, so that's, for example, how we could quickly build kind of like a mechanical looking threading like this. Or, for example, then how to sculpt a threading. And you also see actually that from the beginning, I built this threading actually intersecting into the bottle, so I don't have to move the endpoints later. That's actually why you see there is this flat surface here, and that always is inside the bottle, and then this one intersects into the bottle a little bit. So obviously when I measured my height from where my threading intersects the bottle, so from there down to there. So that, for example, was kind of like my target mark I needed to hit height-wise. Okay, so that about the threading. So the last interesting part now to look at is actually how, for example, we built the cap and the logo. Let's actually start with the cap and those details. So you see here I have actually an array of cubes. So again, my initial cube, rotated so it actually lines up perfectly the way how I need it. And then I have this interesting shape here, which is actually just a line, and then I modify it around, so I have kind of like a cylinder. And for the moment I keep this one invisible. And this one I would like to add to the cap. This is actually cap grooves. Okay, let's go to there. And let's turn all this off. Okay. And this is now my initial cap. You see I have a pretty big rim down here. The rim is bigger actually than needed, and that's on purpose. Now when I will add, for example, the grooves with Boolean union and then the grooves, you see this model has all these grooves added to it. But then I also have this extra flash here. And I tried to build this out of modular building blocks. That means I can easily, quickly adjust maybe one element, for example, those blocks here, and then the Boolean modifier will, for me, easily update the result there. And I want this to be flush, and that is actually where this other face comes in. You see that this face cuts through those blocks. So these blocks are actually bigger than needed. And you see also it cuts through the bottom part of my cap. So if I give this maybe an orange material, then you can see what I'm talking about. There, and let's make this one blue. Okay. So, and I called this one cap side trim. So when I go to the cap, and here's my modifier, then everything I added, I simply trim off flush. Think about it, how would you build this one in real life? Maybe we would carve all these parts out of foam one way, and then maybe at the later we have to clean all the stuff up, so we take sandpaper and sand around it to get a really nice flush look. And that is pretty much what I do with this orange face. Now, instead of cutting all these parts out, it actually in this case was simply easier to have this dummy, and then we calculate all these grooves in, and then we take sandpaper and zip, clean it up. So it was not too difficult, as you can see. Pretty easy. And because this element for the grooves is created with an array modifier, we can always go to the array modifier, either change the dimension of those cubes, we can change the amount we use actually for the amount of grooves we want. Then obviously I have to change the rotation to go back to 100, and then everything is updated. So you see, insanely fast. And that's kind of like what one could consider a generative modeling approach. Parametric, I wouldn't necessarily say. I would call this maybe more generative, because through functions I generate certain structures. I do not model these structures directly by hand. And obviously the advantage of this process is more than evident. It's insanely easy to customize and change those parts. The labor that's necessary is very minimal. The creative output is pretty good. So at the end, it really comes down to do you add elements or do you cut elements out? So let's say maybe let's make a quick variation. So let's take this one out and Shift D. Let's go on to this layer there, and let's go into edit mode there. I would like actually to move and slide this one up. So I will do the following. I will go to normal. You see how actually my 3D widget is aligned up to this edge, and I will save this as a modeling vector. So I go to transform orientations, go to normal, click plus, click here. Now I have edge, and edge I, for example, rename cap edge. Okay. And now I always have it down here. Now I can select this and go back. You see, you don't go back to normal or so, but now I can select this point, and you see everything will perfectly go up along that vector. So this is actually one of the another fantastic modeling parts of Blender, that you can easily create those custom vectors and then make it use it actually for all translation commands. Okay, so now I changed the height, and let's say I would like to cut elements out. I could also say, well, here is a small cube. I'm going to make it simple and fast for the computer to calculate. Then I move this one out. You see I created the object at the world center, and then I move the mesh out. Very important to follow that step. there. And let's say array 150, but not relative object. I think that empty should be there, Nutella empty. Nope, it's probably a different, the array. Let me see, where's that array? Yeah, all has to be on the same height. Ah, okay. So where the object is created, I also create then my empty. Let's scale this one down to 2 centimeters. And then that's wrong. Select this empty. We use 150. So the rotation we need for this empty is 360 by 150 there. And ooh, a little bit too much. So maybe let's say 80, 360 by 80. Still too much. Okay, no, I simply will scale this one down. See, they all the time overlap. Oh, there, perfect. Okay, so because now I could go ahead and say cut this one out, or maybe insert it. So above the edge split difference, you cut those cubes out, hide the cubes, and you see now there we have everything cut out. Just as a variation. Okay. As the last part, let's take a look at the font for the Nutella logo. And I went online and searched for Nutella SVG. So you see here, this is actually a perfectly traced logo. This is actually very good. You see the amount of points very low, and the design is very clean. You see for a lot of the fonts, the E is really bad. So sometimes, and it's the time you spent on trying to find a usable font compared to I just needed to have just the word Nutella as a 3D object. It was simply faster to build it, and then I have top quality and also later data which I can send to Fusion for more work. So you see actually up here I retraced my logo actually with very simple polygon points, and then created three-dimensional extrusions. So small tip in how, for example, I build those letters. Actually not very difficult. So for example, let's maybe start with the T. So I make a plane, scale this one down. Okay, global, snap to this, snap to there, snap, here, W to subdivide with 2 cuts. W you also find subdivide here, there. And then this one goes to there, this one goes to there. E and Y, snap, U, snap. Also here again, subdivide 2 points, snap, snap, and E and Y. And I'm trying to snap actually to those points actually inside the SVG file, and then I delete all this here. So you see inside the SVG file there is an endpoint, and there's my endpoint. Okay, so E to there, snap, E to there, E and Y, snap, E and X, snap, and connect. Okay, so now how do I do this? There are actually 2 ways. Actually, I would do it in this case this way. So we select everything, E and Z, and extrude it up. And now I can, for example, select all this, go to top view. Now because I have two surfaces, I can actually bridge between them. So spacebar, bridge. And let's pull up our menu, maybe 2 cuts, surface, 3 cuts, and then maybe let's play with the smoothness. Okay, and I try to approximate describe this edge. Maybe same here, spacebar, bridge, 3 cuts. Yeah, okay. So, and now we turn subdivision on. And I will select, actually I select all edges, this will be quicker this time, and then say crease, and then you, decrease. Okay, so let's take a look what we have, and you see all these sharp edges perfectly match. These arcs, not 100%, so here I have an edge, and then from there everything, if I turn this one on, you will see it even better. It looks straight, but it's not really straight, so I need an additional edge. And what I will do is Control R, click and move this one over. Same actually also there, not too far away. And you see I try to keep the distance between those edge loops there. Same, for example, there and there. Okay, let's go to your top view. How does this area look like? Not very good, so I might have to adjust the sculpting a little bit by hand. So let's see, if we select these points and move it inward, so I have to deselect this one so I can select through my object. There, let's see, this one maybe to there. Yeah, this is actually pretty close. Okay. Good. So we rebuilt this ladder actually with very few points, and we have the added benefit we have actually a surface and not just a crazy SVG outline, which might be difficult to work with, also in Fusion, because this mesh ladder we can send to Fusion. So let's take a look actually maybe at the A. How would I do that? So so here, for example, I maybe start with a circle, maybe 16, 1 centimeter, scale it down, and let's add subdiv so it's nice and round, and scale it down till maybe it seems to hit the proportions correctly. Tick up and there. Let's see. Looks like actually this has to be scaled along the x-axis, so it's not a perfect circle. Yeah, okay, good. So let's do this one more time, because we have to see how we could close actually this hole here. Oh, okay. Well, actually, you know, I don't need really that many points for that part, so let's say 6 actually will be sufficient for this case. Tick up there, and also here it's slightly squeezed. Okay, good. So, one more time, a plane. Ooh. Zip, zip, zip. Let's scale it, so no, I have to move these points to there, these points go up, this goes to there, that one to there. Okay, so this edge I actually open for a moment, and now I have to see how do I bridge actually now between the ring and this block. So for example, I press E and Y down, maybe till there, and also here E and Y up, till there, click, 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 delete, click, click, fill, click, click, fill, AA, easy up. And let's take a look. Looks terrible because it's all too soft. So now I can go back and select all these outer loops, and then, for example, here those sharp vertical edges or edges to be sharpened, and then either punch in 1 for crease or Shift E, 1, enter. Let's go to top view, and wow, this is actually perfect, nearly perfect match, or very close. I wouldn't say perfect, but if we do a rendering or so, that is totally fine. And then here, maybe let's see what happens if we pull this one down a little bit. That's good, but then maybe this has to go a little bit this way so we get the same curvature. Yeah, okay. And to make things maybe a little bit easier, so what happens if we start thinning this out a little bit? So I remove these edge loops, as you can see. And then, for example, I scale all those apart, maybe to there, S and Y. So I still kind of like work with a circular array. See, now I can actually get to a good result back, but I have to be very careful with the way how I sculpt this part so I don't wobble up this shape. But this is still probably pretty good. How I did it do actually a few days ago. So there, this is obviously more perfect, but it also has more points. And honestly, if you compare these two, you don't necessarily see much of a difference. So what do I do next? And why did I actually do this? So as you can see, I have very low polygon count geometry parts. This is actually first very good for the subdivision surface modeling and also the booleans in Blender. And at the same time, this is actually very lightweight geometry. We can later send actually to Fusion and then continue working with it. Now you would say, well, it's a ladder. Well, why don't we just simply extrude, for example, the SVG file? Well, you have a point, but at the same time, you then have to work with the SVG stuff, and Fusion, for example, is not really super good right now actually working with SVG files in terms of editing it. And because this is a polygon mesh and we resculpted the ladder, we in Fusion also can adjust the geometry when we go into the T-spline module. Plus, we can only, for example, give a thickness to these letters. For example, what you see here in this case with the solidify modifier. So you see there's actually the flat SVG. But we can't really do much more with the top. And in addition, that's the bad part of Blender. When we use a curve as an input, as a surface, and then extrude it, you see it creates kind of like this polygon mesh. So it actually makes things more dense and complicated and less efficient and prone maybe for some hiccups or annoyances. Which is why this process has certain advantages. Now, how do I actually get to this? And this is ridiculously easy. So let me select all this and then Shift H to hide the rest so you see what I have. Also, this line here symbolizes a height of 7 millimeters, and that is the measured height actually of those letters on the Nutella cap. So I know that these letters, because they can perfectly fit in here, also have exactly the right height. And this is also the inner parameter or the circle where the letters sit on the cap. So Where's my cap? There. There's the cap. So you see perfectly matches. So I measured everything and pre-planned it a little bit. Okay, so now how do I get these letters perfectly on this circular array? Very easy. And we do Shift S cursor to selected for the circle. And then I move this one over to there, maybe kind of like the center. GY down there. And in Illustrator, we would make a circle and then say text on path, and then on the circle, type the text, and then Illustrator would kind of like slide those letters along the circle. Now, because we only have 1, 2, 3, 4, 5, 6, 7 letters, we can easily do this by hand in Blender. I set 3D cursor and then, for example, select N and simply rotate it. And I select this one, G and X to there. There, see now this has to rotate it, tick more. And then I rotate G and X till it's centered. This is a little bit too tight, so R, there. Get over. The E is pretty wide, so I might need some extra space here. So you see, I do the spacing of these letters manually by hand. It's not very complicated. If you have a lot of text, it might be a different situation. And the advantage of this is also, because I do this by hand, I can do it by hand, which is actually really nice. So there, and then this one actually I rotate over to there, and then zip, 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 and there. Okay, so you see, that's basically quickly the way how I created all these shapes. Now, these are individual objects, and when I would like to cap everything, I don't want to have to add too many commands for the Boolean. So what I do now is the following. I simply Shift D, escape, make a copy, and then Control J and join everything together. So now this is one object now. And I could, for example, say set origin to the 3D cursor. So that's Shift Control Alt C, or you use the menu inside the toolbar. And now I could, for example, apply the rotation. So now this is all set to 0. And now I could, because I have 4, say Alt R 90. Oh wait, what happened? No, Control D R 90. Alt D R 90. Alt D R 90. You see then this way we multiply. But now again I have 4 objects, 4 commands. So let's make a simple axis. For example, scale this one down to centimeters. Okay, 360 divided by 4, which is 90. So, and then U, array modifier, 4 steps, no relative, offset this empty, and there we are. Zip, perfect. Okay, so let me delete this, because I have this already pre-built, but this is basically the way how I created then actually those letters here. So you see subsurface, Boolean array, and then I have actually the array and then a Boolean command, and that Boolean command caps actually the top. See, now this is hollow. So why did I do that? Well, the thing is, if I have my cap, I need to have a 3-dimensional model, sort of volume or something. or shell that can describe a volume to add to the cap. Currently, I just add volumeless letters to the cap. That's not really very good. So what I did was, you see it here. Let me make it visible again. It's simply a flat plane. And that plane basically cuts the top part of my letters off and then fills in the space inside the letters. That's all the trick I did. There. And then that, for example, so these letters are then added to the logo. Now with the height, for example, of this part, so this plane, I can actually decide how high, for example, the letters are. So you see, the more I move it up and down, the more I shorten the height of the letters. So now you would say, nah, class, you could also do this simply with an extrude or solidify to adjust the height. True, very true. However, there's something else I can do now with this plane. So for example, I will subdivide this one time and then maybe, hold on one second, there, add a subdivision, and there. These points I select and scale this in a little bit. I try to turn this somewhat into a sphere, there. And for example, this point now I move down, let's say to there. The opposite, actually, I move up and down. Okay. And you see actually now that the letters are not linearly capped to the center. They get thinner, to the outside they get taller. So that's for example the reason why I took the time to redraw one logo with the sub-D outline extruded into a vertical shell, because then with a cap surface I can trim it, or trim it and at the same time sculpt, for example, a certain design. And because everything here, the letters are in a circular array, I can create kind of like a half dome shape and then change the way how the letters look. I think if maybe we make this even lower, could make, I think, even the letters appear out of the cap. Yeah, there. So see there, they're coming. Okay, that was basically all the magic to how to create this logo letter, how to add it to it, and then be a little bit more creative with the way how we could style the way how those letters can actually look. So to finish this design, we also have to add the contour threading actually to the cap. So for example, I can make a copy, Shift D, and then I will turn off those Boolean modifiers, for example, cap start, I should name those correctly, cap end, okay, zip, okay. And let's see, so there's our part. Now I have actually this outline here, which really is very helpful for me to get a clue in where I have to position my objects. So what I can do now is, with everything selected, go to bounding box center, and then let's see, this is actually also oriented along the x-axis, which is perfect. So Control MX, so we just flip it. This actually looks inverted, so flip there, okay. And we might have to move this one up, G and Z, and snap to this point along the x-axis, X and Control, okay. So But now I have to see how far does this maybe touch the threading. Actually, the threading touch is pretty good. Does it touch actually the bottle? It's getting close, so I add a little bit of a hair gap in between. Perfect. So things are less confusing. I simply put this onto a different layer. And then I make Alt D a copy of this part, M and there, because obviously I have to also trim the part there, so I have to move this one up accordingly. Okay, and then cap start. Nope, wrong one. Use that one. Let's take a look. Okay, but as you can see now, this is not the correct orientation. So let's see what we can do here. Actually, this one I think has to be mirrored, and let's try to take a look. And yeah, so we can't really reuse the same object there, so we have to build our own there. So I made a clone copy, and you see here when I go to the object, to the mesh data block, it says for users. I click on it and it's gone. So for example, I could call this one threading cap cap, or not cap, and trim cap. So I know this is the geometry for the and trim for the cap object. And then here, these points, I simply move to there till this whole thing, as you can see, perfectly cuts through it. Great. Okay, so this whole object, now Alt D, I can make a clone, move this one up. And for example, R and Z, whoops, along the 3D cursor, R and Z there. And what's going on there? Interesting. Oh, well, it doesn't really cut through. Makes sense. There, it has to be that way. Okay, but there's a tiny issue we have. So let's take a look up here. Yeah, let's see if these parts were actually rotated. So there, are these actually joined? Same mesh, same mesh. Oh, come on, this object has to be rotated, isn't it? Yeah. And then there and there. Yeah, okay. So this one, let's actually rotate this with this value RZ, Control V, minus, so it's back. Okay, so I need to change something here, and that's actually, I will delete this for the moment, and I will place my 3D cursor there at Y0, and then set my pivot point to the 3D cursor, because with this done, I can actually Alt D, escape, Control M and Y, and you see I flip it. Okay, so that's the reason why it didn't show up the rotation. And the way how I did it is actually, as you can see, it worked with the scale. So the flipping, actually the mirroring, inverted the scale a little bit. Okay, because now I can bring this one up to where I need it. Shift Z, cursor to center, switch back to the pivot point, R, rotate it over. Let's adjust this correctly. Okay. And now we can add this. Let's take a look. Yeah, and this looks better. Okay. So, and then this, for example, we could call threading Boolean cap. So I know what threading it is. And then if we go to the cap, let's pre-check it to see if it's all good. That's a tiny issue. You see, actually, it sticks out a little bit. So let's make a cross-section look. Probably we can fix this by simply not making the threading go into the body as much. Okay, so let's see, where's our object? There. So these points, bounding box, I move in a little bit. Also, the cap actually gets, as you can see, thinner to the top, so it slopes a little bit. So this probably should do it, and it's still inside the object at the bottom anyway, and the second turn as well, even more. Okay, good. So now with this fixed, we can go to Boolean, put this in front of this match and the edge split. This always should be the last, because this always cuts edges for me, it breaks them. But if edges are broken, then basically the surface is open and then the Boolean modifier will fail, which is why it should always be in front. And let's say threading union, and then threading Boolean cap. And I call this one threading Boolean because that's simply the process I use to create those threadings. I trimmed them, so I made use of Boolean operation. Okay, so there is now our completed design. Let's make a cross-section look to see if everything fits, and yeah, as you can see, the threading is pretty awesome. All is good. There's enough space in between, no interference. So this, for example, this geometry model would be obviously not okay to send to manufacturing. We would have to do a little bit more work to it. But this actually is perfectly sufficient, for example, to rapid prototype. So this is a little bit not as precise as needed, but sometimes when doing something like this in an engineering tool, you get more precision. It just takes a lot longer, and you're not as flexible. So for creating a quick idea and sculpting something like this, this process is really more ideal. Because specifically when we make a prototype, it's more about touching it, maybe testing an idea. It's not really about fine-tuning everything for manufacturing. Okay.